There we go. Okay, thanks everyone for joining. I will pass over now to Martin.
Thanks very much for that, Will. Yes, thank you for this opportunity to present to the British Hydrological Society. My name is Martin Borthwick. I'm a senior hydrologist working for the Environment Agency, and I work in the Flood Hydrology Improvements Programme. Just to introduce my co-speakers today, I'm joined by Andrew Chiverton, who's the Hydrometric Open Data Project Manager, and he'll say a little bit more about what he does when we get to him, and also Rolf Farrell, who's a groundwater specialist, groundwater technical advisor in the Environment Agency as well, and Rolf will be speaking shortly. So just to give you a quick overview of what we're going to be covering today in this Making More Hydrometric Data Open Access. So we're going to have a look at the context of hydrometric monitoring in terms of how we get to open access data and the value of that data to us. And we're going to use an example from our groundwater network, and Rolf is going to take us through that. We could spend more than one presentation talking about the different features of hydrometric monitoring, and clearly we haven't got time for that when we want to then get to the hydrology open data service itself, which we will then come to. So I'll cover that, introduce how we've evolved the system and what it offers us, and Andrew will then take us through a deep dive into the key features then of the Hydrology Data Explorer tool. And I've popped in the chat a link to that if anybody wants to open up and have a look at it as we're going through, and we will provide some further links later on as well. And then we'll finish up with a little bit of future direction, searching and seeking, and provide some time then for questions from the audience. Okay, so I'm going to hand over to Rolf now, who's going to take us through the first part.
See. Right, can everybody see that?
Looks good for me, Rolf. Yeah.
Cool. Okay. Yeah, I'm going to give you a bit of a background to our groundwater level monitoring network. We could have easily done this for any of the other networks, but as Martin said, we had to stick with one, so it was Groundwater's win this time. And what I'm going to do is give you a bit of a background to how the network evolved and how it comes to be what it is today, and how that sort of effectively ties in with the work that we've been doing to make the data actually more accessibly available. And so it all begins at this location called Place House, Hartlip, near Sittingbourne in Kent. This is a house that was built by a gentleman called William Bland in around about 1810. And as part of that work, he constructed a borehole to supply water to the house. And for reasons which I guess is typical Victorian amateur scientist kind of thing, he decided that he would monitor the groundwater in this borehole. I just want to mention here, since we're talking about open data, these scans come from the rather excellent British Geological Survey GeoIndex, where there's thousands and thousands of borehole records, and I'll mention a little bit more about that later. And I'll also draw your attention, sadly, to the line in the scan there saying the borehole was filled in 1958, which is no doubt when Place House got its water supply. Mr. Bland, though, he in 1819 started recording the groundwater levels in this borehole, and he did so for about 12 years until 1831. So what you're seeing here is, as far as we know, the earliest hydrometric groundwater archive anywhere in the world. And he reported all of this in the Philosophical magazine. This is what the hydrograph actually looks like. So that's obviously your first groundwater hydrograph. Sadly, the borehole was lost, but we do have a borehole that's been operating since around 1982, White Gates Farm, that's not that far away, and kind of carries that legacy on. And you can see that borehole on the Hydrology Data Explorer. Mr. Bland wasn't just interested in temporal variation. He also went out and did a few cross sections, and he went out with some of his friends, including the traditional Victorian vicar, and that's what he produced. So he was able to put some sections together, and so we're starting to get our first sort of three-dimensional look at groundwater as a result of this work. But this was, as I say, amateur work. It wasn't until the 1870s, really, that we actually started to see the first professional network of the sort that we effectively have today, albeit on a small scale. And this is the Surrey Street Pumping Station in Croydon. It was opened in 1951 by the Archbishop of Canterbury, no less. And it was a big thing because it was the first town to have a combined water and sewage system. But at that time, as you might guess, Croydon was expanding at a very significant rate. You can see that actually in the photograph in the different architectural styles associated with the pumping station. And each of these parts of the building were constructed to add new pumps in. And so by 1866, they were pumping 1.5 million gallons a day from a 22-metre deep borehole. But before long, there was a problem, and it's a very contemporary sounding problem. We had local millers complaining about loss of flow from the River Wandle. Now that was rejected, and flow did recover. One thing I quite like about this is that you can look at our first surviving borehole from that period that is still monitored today, the oldest one that we've got, Chilgrove, which started in 1836. And if you sort of look around the sort of late 1850s period, you can see that certainly groundwater at Chilgrove, which is sort of nearer to the south coast, was pretty low. So I don't know whether they used that information, whether it was publicly accessible at the time, but you could certainly see that having knowledge of that groundwater level data would have actually supported the case that it wasn't groundwater that was causing the problems on the River Wandle. But the outcome of this was that the water company obviously realised it was vulnerable to that kind of challenge. So it started looking around in the catchment area and identified a number of boreholes. And when you overlay the geology onto it, the sort of pale grey colour is the chalk. And so we're looking at a scarp slope. So top centre is Croydon itself, and that's basically the catchment area for the Surrey Street pumping station, and effectively it's the first groundwater level monitoring network that we have. So it's quite a significant outcome, and as I said, caused by very modern kind of issues. So that's where it all began. Where we sort of all are now is, well, we have here a geology map. That's obviously what drives the sort of groundwater resource issues, and hopefully the pointer will show up. You can see in pale green up the east coast and round into Wessex and south of London in the North and South Downs, the pale colour of the chalk, our principal aquifer, and a little bit less easy to spot in the Midlands, the sort of pale pink colour being the Triassic sandstone, which is the other major aquifer that we have. And this is the borehole log viewer, and now I'm running out of power because my... Excuse me a moment. Yeah, would you believe the plug socket doesn't work? That should be better. Sorry about that. These are our principal aquifers, and you can see these on another great piece of open data, the geology viewer that the BGS does. And what that all relates to then is a bit more clear to see now is the principal sandstone aquifers, at least the groundwater models that we have built on them. So the dark orange is where we have groundwater models, and the pale yellow is outcrops of the sandstone in places where various reasons we don't feel the need to model. But you can see the red dots, which is the monitoring network, and how densely some of these areas are actually covered by the network. And if we look at the chalk, it's a similar story. Here we have the pale green of the chalk and then overlying deposits in the sort of buff colour. So you can see the preponderance of locations focused on the outcrop of the chalk. And if we zoom in a little bit more carefully now, actually, if we look at where the groundwater models are, these are pretty much covering almost the entire outcrop of the chalk area. So we're investing an awful lot of money into modelling these aquifers, and the principal data input into those aquifers are the chalk monitoring boreholes. And when you zoom in a little bit more closely, you can see how the distribution works. That again, on the confined chalk, where the buff colour is, there's not that much monitoring going on. Most of the resource is in the outcrop area and most of the sensitivity there. So a lot of these red dots are quite close to streams. So we're really focused on how surface water is impacted by groundwater abstractions. And yeah, I mentioned how Surrey Street network evolved. Well, that was a tiny number of boreholes, about 30 or so. And this is how the national network has evolved over the years. You can basically see that not a lot happened until really the late 1950s. And this is in response to the 1963 Water Resources Act, which required the water companies to actually have some vague idea about what was going on and what the consequences of their abstractions would be. So I suspect that people back in the late 50s started to see which way the wind was blowing and start putting in monitoring locations. And there's a very steep rise in the number of boreholes being put onto the network at that period of time, mostly constrained by the rate at which people could drill boreholes. It's a mixture of new boreholes constructed for the purpose and existing private sources and the like. And you can see that it tops out in the during the 1980s, and the bit that I don't really like to focus on too much is what's happened since 2000, where the number of locations has dropped rather significantly, and it's a problem that we're trying to address in the agency. And it's a problem that's relevant to the work that Andrew's been doing in actually developing the Hydrology Data Explorer, because what's hidden in this histogram is just for clarity, it's showing the number of active boreholes per year. But of course, what's happening underneath that is lots of boreholes are being lost and new boreholes added. And so what that means is that all the time we increasingly have a number of significant archives which are not currently visited anymore, and those are the sites which are not currently on the Data Explorer, but which we intend to put on them. And this is the same plot again, number of active boreholes per year of the logged networks. The previous one was just everything. Most of our boreholes are still manually dipped. I'm working on a project to try and fix that, but this is what the logged network looks like. Some of the early ones are actually just where records that are now logged have been sort of joined on to manually dipped ones. So we weren't really doing any logging in the 1960s, but the same story applies. We've got a significant rise in the implementation of the technology during the 2000s and a little bit of a fall off since. And this is the last slide before I hand over to Andrew. Again, this is sort of highlighting the value of open data. So this is the borehole scans, which I showed you in the first slide of Hartlip. What happened here was in 2010, the BGS replaced their manual inquiry system with the borehole log viewer. And so if you look on the left-hand scale on the orange line, at that particular time, about 750 boreholes per month were being requested by people. But since then, looking on the right-hand side, we're now at a point where about 125, 30,000 more if you ignore the spikes, and maybe a lot more if you do. Yeah, basically it's a six-figure sum of boreholes per month that's being requested by people. And if you collect data and you don't look at it, then there's no value in that data. So obviously, the more it's used, the better. And this is actually what I'm hoping we'll find out a little bit more in the future about the amount of use that's being made of the Hydrology Data Explorer. But that's it for my bit. Yeah, I'll hand over to Andrew now.
Actually, it's me next, Rolf. Then Andrew, thank you for that. If you want to stop sharing, I'll share my screen then. Okay, I hope you can all see that now.
Looks good, thanks. Yep.
Good, thanks, Andrew. Okay, so on to bringing things forward then, as Rolf has just taken us through some of that, the context of one aspect of our monitoring. Then let's look at how we've made this data available through the Open Data Project so that it's publicly available. Let's put this into context. The Hydrology Data Explorer sits within a service provided by DEFRA called the Data Services Platform. And DEFRA, in fact, publishes a huge amount of data on our behalf, on behalf of others. There are some links here, which we won't go to in detail here, but the Hydrology Data Explorer sits underneath that, and you can easily get from the Data Explorer into the broader set of data that DEFRA hosts as well. And it's worth having a look at that. It covers a whole range of different areas of interest, which may well be of interest to you in the audience. We're going to focus on the hydrology side, and in particular here on rainfall, river flow and level, groundwater, and some of our telemetry water quality data. But it's impressive, and it doesn't just come as data sets. It's available through applications and through APIs, and I'll say a little bit more about APIs as we go forward. So where did we come from? Well, Andrew Chiverton is a key player in this, which is why we're glad to have him on the call to take us through the Explorer. He's been a pioneer in a way, working with colleagues at an area level within the Environment Agency, initially in 2018 through to 2021, in developing a sort of pilot, a proof of concept for what was then called the River of Change project. And that was in response to requests from external customers working with water abstractions, requiring data from the agency. And that demand for data obviously takes time to turn it around and present the data back. And so this pilot system was developed in order to be able to make that data more freely available. Initially was focused in the Devon and Cornwall area, and comprised a user interface and an API, which is an application programming interface, and that's a means by which we can one can automatically download data using scripting. And that covered about 900 sites and largely focused around daily mean flows and a small amount of groundwater. Over time, that gained a bit of traction, I think, as we've seen from what Ralph was showing in terms of sort of how people, once they get access to data, then they can look at it more often and get better use out of it, harvest it in a way, and so its demand goes up. And to kind of give you a feel for that, the lifetime of the Hydrology Data Explorer as it has been developed from that initial pilot project through to what we had at the very start of this year, which was the existing system, which was largely daily mean flow and some rainfall and groundwater data. To give you an idea of what that sort of demand was, that data has been accessed in an 18-month period over 100 million times via that application programming interface. So automation, as you can imagine, very large number of calls on that, but about 10,000 calls in a month via the user interface. That's kind of individual sort of requests. So that gives you an idea of that kind of that scaling up of demand as a system becomes available and becomes used. So why more then? Why add more? It seems that seems successful. We're okay with that. And we do collect a vast amount of data, so why not, in a way, make more of it available? But it's got to service a need, and it's that balance between what we've got and what's useful and what end users require. What is the demand? And there is considerable demand from water resources assessment work, the sort of work that Andrew's been involved in, for abstraction work, hydropower and so on, but also flood risk assessment side, which is what I'm involved in the flood hydrology improvements program, flood risk analysis, and also for research, being able to take those data sets and be able to researchers apply scientific techniques for developing new methods, new models going forwards to help drive that science ever forwards. And to give you an idea of the amount of data we're talking about, we collect data from around about 1,000 rain gauges, that's continuous recording rain gauges, about 1,200 river flow sites, 2,500 river level sites, and about 5,000 boreholes. So there's a lot of it, and that's the advantage of having this system developed in this way, where it can bring it all together under one heading. And the advantages are obviously in terms of resource economy. Large numbers of requests are going to be a problem in terms of turning those around. So being able to have data available sort of at your fingertips at the touch of a button has got to certainly improve that, and has definitely been beneficial to us and absolutely to end users. But also that opportunity for that sort of drive to improve the science, and we're hopeful on that by intelligent and careful use of data going forwards, we can see improvements through the research world endeavors in developing new methods for analyzing this data. So that we're hopeful on that front as well. But it's worth then having a look then at how we've moved on to what it's the current upgrade, which was made live at the end of March, beginning of April this year. So it's now been running for best about part of 8 months. So this enhanced Hydrology Data Explorer. This came about through cross-organization working, so several different teams working across Environment Agency, working in conjunction with DEFRA Data Services Platform to bring this service into being. So this major upgrade is to add in primarily sub-daily data to that daily average data, and that's across a range of hydrometric data sources, so rainfall, river flow, river level, and groundwater. And that's in response to end customer demand for the sort of applications that I've just been talking about. And that's available through this user interface, which I'm just going to show you, and also through this API application programming interface. And for those of you who are users of that technology, the scripting for that, just one polite request that if you do want to make significantly large volume downloads from the service, we would ask that you just get in touch with us through the link on the website, just so we can work with you to ensure that data is available to you, at appropriate times and an appropriate rate, just to make sure that the service works well across all users, that it doesn't get bottlenecked. Okay, so the other thing I just wanted to say just briefly just about the sub-daily data, and it's particularly valuable to us within flood hydrology. A lot of the modeling work that we do on event-based estimation of flooding, what happens, what are the impacts when floodways pass, say down through rivers, is we need that sub-daily, that 15-minute or the hourly data to tell us how the flood levels are changing, how the rainfall is changing, so we can run our models and make appropriate assessments of the risk of flooding and the impacts. So that's again provided a huge benefit to those end users too. So what kind of coverage are we talking about? Well, we've scaled up from what was about 25 million data points to over 4 billion. So this is arguably one of the biggest online hydrological archives now in the world. It covers our open stations, those stations that are operational, they still collect data, and it's the whole period of record that's taken from our digital archive called Whiskey, and it includes some basic quality flags, which Andrew will point out in the demonstration shortly. The other aspects of it is in addition to that archive, we've brought in telemetry-fed data. So that's data which comes with our, if you like, real-time monitoring. It's got a short delay, around about 40 minutes or so, and that's for all our river level, most of the rainfall sites, as well as for selected locations in the southwest, some of the river flow and groundwater sites. And obviously, as more of those sites become available, then that will be added in the future. And the advantage with this is that you're getting that real-time data. The thing to be aware of, it's raw data, it's not been checked. And that's something that we put a lot of effort in the Environment Agency. Our colleagues in hydrometry and telemetry go out and check the plausibility and reliability of measurements made as best as is possible, and then go back and correct records, deal with where they can, missing data, potential infilling, and provide some sort of indication back as to what the quality of that data is where we can. And it's important to realize that unchecked data may change. So what then gets overwritten in the WSGI archive and then is then exported back into this Hydrology Data Explorer may be different to what it was when it was first drawn in through telemetry. So just be aware of that. That very recent data may get overwritten, but it's important that we do that. That updating happens at different rates. For some of it's daily, for daily river flow and rainfall. Sub-daily data is updated on a monthly basis. The maximum and minimum values similarly on a monthly basis, and dipped groundwater each week. So it's a little bit of a patchwork in a way. That's something that we're working on in the future to streamline that. And the other aspect that we've included is, as I mentioned earlier, the telemetry water quality data. And that's from continuous water quality monitoring sonde sites where they're deployed for an extended period of time. And that's data for up to 10 water quality parameters. I should say they're for non-commercial sites that are not currently sub-judiciary, for which we've been granted permission to release. A couple of final thoughts from me before I pass over to Kanju for the demo. It's about keeping it real. Open data isn't completely free as such, so it's free of charge, but it's not free of responsibility. Any measurements made in the natural environment are subject to uncertainty. As I mentioned, we put effort into checking things and doing our best to ensure that the data is as good a quality as we can get, but nothing is perfect. And clearly that uncertainty is also related to what you as end users intend to do with the data. Are you interested in low flows, high flows, volumes? What might it be? And the checks then that you're responsible for go with that. You know, what are the plausibility of the data that you can see? How does it compare with observations from neighboring sites or other data sets? It's important that one that bears that in mind. And also this point about just things getting changed and overwritten as we do those checks. I included this photograph. It's from earlier this year, shared from a colleague in HNT, hydrometry and telemetry. So here we see a log, bit of debris stuck on the top of a weir, causing a blockage. Most of the time you don't know that that's happened, but if you look at the trace here on the bottom right of the screen, you can see a sudden increase in the water level recorded. So that's data that would come through the telemetry. But of course, whilst the measurement's correct, the water level did go up, it doesn't reflect what's truly going on and needs to be corrected, because if that data was to be processed and used for some further analysis, so to estimate flows and so on, if we had the rating curve for that site, well, then clearly we'd be getting erroneous results. So enabling that checking to happen, checking back to see that the data sets that you've got have been checked, and making those appropriate other careful use of the data by looking at its uncertainty is really important. So I'd say that open data arguably is only as good as its metadata, but it's definite progress, as Rolf was pointing out, in terms of demand. And the final thing to say from me is that some of this open data has been here a while before the Hydrology Data Explorer, and one I want to point out particularly to a number of you in the audience would be about the National River Flow Archive. That's a very rich data set. That peak flow data set is the definitive source for annual maxima and peaks over threshold data used for flood estimation work. So that hasn't changed. That's the go-to for that. The Hydrology Data Explorer is not a replacement, but it adds to that, it augments that. So please bear that in mind. And if you're interested in flooding in particular, about flooding in a particular area, your area, there is that check for flooding service. Please use that. There are links on the Data Explorer to that as well. That gives you information about flooding, but particularly about flood risk, as well as 24/7 support. Okay, I'm going to stop sharing and pass over to Andrew at this point.
That's brilliant. Thanks, Martin. That's good. Our fingers crossed you can see my screen. So yeah, so I'm just going to give a quick demonstration of Hydrology Data Explorer. briefly comment on a few plans we've got coming up, a few challenges we've got, and then hopefully there'll be plenty of time for questions. So when you first open up the Hydrology Data Explorer, you're greeted with a pop-up box. This often doesn't change and just has various informations about our other services on here, but we do put messages on here when we know there's going to be periods of downtime. So if you notice data isn't updating, please just check this pop-up box for maybe a good reason why it's temporarily not updating. In addition, we've got a feedback form at the top. I'll just encourage everyone who uses this to either get in touch and provide us with feedback or use this feedback form. Your feedback really does help drive future improvements, as well as helping us justify the money we spend on this service. So good, bad feedback is all very welcome. It really does help us invest, improve and maintain the service. So service, the user interface is based around a map-based interface. All the points are plotted, all the gauging stations are plotted on the map. We use the UKCH river layer, so you can turn on the rivers in the background, and that helps you find the gauging stations you're interested in. As previously mentioned, we've got groundwater, river level, river flow, rainfall and water quality sites, and you can turn these on and off and filter them as you like. This water quality archive should be used in conjunction with our it's called Water Quality Archive. This is our real-time water quality network. So we've got, as Martin said, instruments out in the field which are constantly sending data back to us, and these update in relatively real time. And for each of these, we collect up to 10 different parameters on here. So it tells you the latest reading, the latest dissolved oxygen reading at the top left, and then you've got a data selection portal where you can turn on and off different parameters. They'll appear on the graph, and you can download the data and change the data as you see fit to meet your needs. These records are quite often short because we deploy these in places of interest for usually a number of weeks or months. So you can see this record is only 7 weeks old, quite different to our hydrometric network, particularly the ones Rolf was talking about. But moving on to our sort of water quantity side, let's pick a river flow site. It's got the same features. Top left-hand corner, it gives you the latest river flow, because I picked a river flow site. You can see the length of a record, and you can change the data which is displayed on the graph below. So the river flow sites default to showing daily mean river flow, but if you're interested in our sub-daily data, you can change that to 15 minutes, or you can change it to river levels. You can also alter the dates of the data which is selected, and then the data will plot below. As you can see, this data's about an hour old or so. So we've got the historic data going all the way back to 1956, as well as the live data. I'll turn this back to daily and show a bit more than show a year's worth of daily data. We've tried quite hard to indicate what's being quality checked and what's raw data. So everything with a dotted orange line is raw data. As Martin pointed out, it's very valuable data, but you treat it with caution. A human hasn't looked at this data. It's just in its raw form for you to use. And then a solid blue line has been quality checked. We've also got quality flags at the bottom. So the grey bar shows periods which are good, and anything which is highlighted in orange, there's some reason to be a bit cautious when using this data. So for example, the data above my cursor here has been estimated. So there have been some period of missing data, and our H&T colleagues have gone in and infilled it with estimated data. You can also download the data as CSVs, download the full record, the bit you're interested in. And we've got all the different parameters down here. We've got a daily maximum, daily minimum, 15 minutes, and daily mean values, which you can download. On the right-hand side, we've got a bit of station metadata, grid reference, station name, station reference, and station ID. If you do need to get in touch with us about any of these gauging stations, it's really helpful if you include the whiskey ID. Just helps make sure, because a few of our stations do have very similar names. It just avoids any ambiguity. And we've also got links to partner organizations and websites. So we've got the National River Flow Archive. So if you click on this link, it'll take you to the same gauging station, but on the NRFA's website. I very much recommend you go over here for background metadata. They've got a lot more information on about the actual gauging station than we have on our website. Should have mentioned before, we've also got some filters on the right-hand side, so you can filter based on dates, and that'll bring back any station which has got data between the dates you select, or you can search by various texts, postcodes, NGRs, etc. And then behind all this, as Martin mentioned before, is an application programming interface, which stores all the data. So if you are interested in writing computer code to extract this data rather than going through the user interface, there's pages and pages of information here about how to structure API queries, which I won't go through today. So I'll pause the demonstration there. I'll go back to if anyone's got any questions and bring up the presentation. So fingers crossed that's showing on the right screen. It's hardly got multiple screens to know exactly what's displaying. So I've been working very hard on some future enhancements. There's one which is coming out in the next couple of weeks, which is the ability for us to add closed sites. Rolf spent a bit of time showing the importance of that. Our network grows and changes and sometimes shrinks through the years. And there's a tremendous amount of valuable data in our sites which are currently closed. So we're working very hard to populate these over the next 6 to 12 months. So our first closed sites hopefully being available before Christmas. We're working hard to get more frequent updates. At the moment, we've got obviously the live telemetry data, which updates very frequently. And then our whiskey data usually updates once a month. We want to make that more frequent, so the QA data is available sooner. We're in the process of making improvements to the user interface, and that'll become quite apparent if you log in about a month's time, because all the blue dots I've shown you will then be different colours. Groundwater will have its own colour, as will rainfall. And we want to enhance the metadata. And one bit of metadata we are working hard behind the scenes to try and provide is some indication of site data quality or uncertainty, but as I'm sure you're aware, that's full of challenges as to how to calculate uncertainty, how to display uncertainty, etc. But we are working hard, and any thoughts on uncertainty calculations, more than welcome. And then my final slide, and we'll send this round so you've got all these links, is where to go if you've got any queries or feedback. And I say, please get in touch with feedback. It really does help us. You know, this is a shared hydrological community asset. It's not just for the Environment Agency. We really want it to meet as many user needs as possible. And we only can understand your needs if you get in touch and let us know. So please get in touch. So you can get in touch either by hydrometric open data, but there's an extra T in there, only one T, at environmentagency.gov.uk, or use the feedback form at the top of the page. There's a handy link here to a flood hydrology improvements programme, which talks about what Martin and his colleagues are working on, and it's got some really valuable information there. If you've got queries about specific data sets, so there's a specific river flow, rainfall gauge, whatever it is, that doesn't quite look right, I'll please ask that you get in touch with our inquiries team, and any queries about the water quality data, the water quality network, please get in touch with our National Water Quality Instrumentation team at nwqis@environmentagency.gov.uk. But we'll make sure that this slide is shared of yours, so you've got these links. So I'll pause there and see if anybody's got any questions.
Brilliant. Thanks, Andrew. Thanks, Martin and Rolf. I can see some questions coming in. I'm going to jump in quickly with a question of my own, if that's okay, and then I'll pass over to Liv, who's gonna convey some of your questions to the speakers here. I'm interested if you are collecting or are collecting information on how this data is being used, and if there's been any unexpected consequences or no consequences, maybe not, any unexpected uses of this data that has been interesting, or that you didn't think of when sort of setting off on this journey.
It's a good question, and because it's all open data, we actually know very little about how this data is actually used, unless people get in touch with us and say we're using it for this application. A few interesting things. One is about 20% of the API requests we get for this data are from abroad, so it's obviously use not just in this country. And there's just a fantastic array of tools which are being built for quite specific use cases. We only know about them usually because someone has a bit of a challenge and gets in touch asking for a bit of help for us to help them with the tool, really. So they're and they're not publicly available, so I can't really share them. But there's some really interesting work going on across the water network, water companies, consultants with this data. And then if you look at what National River Flow Archive do with all their drought tools and things, yeah, it's another really good example of how this data can be used. And yeah, if anyone has got any interesting use case, we really would be interested in hearing them. Again, they just help us justify why we're doing this.
Brilliant, thank you. Liv, are you okay to convey some of the questions that have come in?
Yep, sure. So I'll start with one that Hannah Lewis asked, but and Wolf has very kindly answered in the chat box, but just in case anyone's missed it, I hope you don't mind, Rolf, just going over it again. So the question was, it might come up, but are there any plans to make groundwater models or outputs open access in terms of their level, as in at risk of flooding or similar, if the flood warning system, to create a similar flood warning system as on rivers? Are you able to answer that, Rolf? I know you've already typed something out for us.
No, that's fine. Yeah, it's something we've wanted to do for a long period of time. We developed about 15 years ago the National Groundwater Modelling System, which is based on a Delta's Dutch system that we also use to do the flood forecasting with, and that has an external face or potentially external facing web browser, so some outputs can be provided on that, but the data that goes into the groundwater models is rather more complicated, and we've got in particular IPR related issues. Soils data and evapotranspiration data comes from elsewhere, so sort of making that data available publicly in the past has been difficult because you'd need to go to other organizations for licenses. I think that's sort of changing a little bit, and this whole sort of move to open data is obviously helping, and we're now moving to a new version of the system which has is cloud-based and has a lot more sort of capability for enhanced web type services. So we might either be able to use that to provide lots of relatively controlled output, or ideally we would like to make the models themselves publicly accessible in some form. We just have to be careful though that system resources are required to run them. It can take sort of potentially a day to run a single scenario. So how we do this is difficult, but we just kind of come to the completion of a project to update the system. I'm not planning on doing anything at all next year, but after we've settled down a bit and got the hang of it, we will be looking at what we can do to provide access more widely to the public and key users such as the water companies. Sorry, and just on the flooding side of things, yeah, it's always a challenge. We've got separate mechanisms or systems for doing groundwater flooding, but it's difficult with the groundwater models because when they flood, you're looking at parts of the aquifer system that's actually not normally saturated, so it tends to do weirdly different things. So it's quite a challenge to produce output that you'd be able to make a safe conclusion on without a lot of technical knowledge, really. That's it.
Okay, thank you so much for that, Rolf. And the next one, we've got 3 questions for Andrew, if that's okay. So starting with Vicky Shackle's question first, how do you, or anybody, see the HDE and the National River Flow Archive coexisting in the future? So the Hydrology Data Explorer and the National River Flow Archive, how do you see them coexisting in the future?
That's a really good question. There obviously is overlap between the 2 services. We do work very closely together. As you can see, we've got the links that go from the HDE to the correct station on the NRFA, and they've got reversal links that will send people back to our systems. Although there's overlap, I do see them having quite unique functions as well. So it's a balance. I don't see us replacing the systems with one system, but I would like to get them more harmoniously linked together. And one big project, which is unfortunately going on for a little bit of time now, is to make sure that the data on the 2 systems is identical. So reconciling the historic data, which for a small number of sites can differ between the 2 services. But now it's something we're very aware of, that we've got 2 systems that are different, do meet different needs, do have different functionality, but are similar.
Brilliant. The next question is, when updating Whiskey on a monthly basis, is the data updated for the period of record within the Hydrology Data Explorer at the same time, or is there a delay?
Sure. So when we update it every month, we extract just over the last year's worth of data, and that brings through most of the QA data by H&T teams. However, if our hydrometry and telemetry colleagues do rating reviews or other things that change data which is more than 12 months old, they'll then do a separate export of that data. So you may occasionally see long periods of record change with no notice, and that's usually when H&T have done a rating review change or data quality check that's gone beyond a year, and then they've exported that data.
Okay, brilliant. And then our last question is, when downloading the data, I note there is a large amount of redundancy in each line of the file, meaning that the size of the file is really large. Do you have any plans to remove the unneeded text on each line in the file? For example, a river level series I just downloaded was 170 megabytes, and that's from Matthew Cowdell.
Thanks, Matthew. Yeah, it's a good question. We are aware of it. It's not a trivial, although it may seem quite an easy fix, it's not a trivial upgrade to the service. So we don't currently have any plans to reduce this, but it is something we are aware of, and I'm sure we will get around to in future time to streamline the downloads.
Brilliant. Okay, and then I think that was all of our questions for today. So thank you very much. I'll hand back over to Will.
Brilliant. Thanks, Liv. Yeah, just again, just to say thank you to our presenters today. I found that really insightful, really interesting. This recording will be up on our YouTube channel, so please feel free to check it out there. And you know, as Andrew had in his slides there, I assume everyone is happy to be contacted if they have any questions or follow-up questions on this. So thank you very much. Just a quick plug before everyone shoots off. next week we have the BHS has a webinar covering 10 years of the Cosmos data set and project. So that's happening on the 29th of November. So keep an eye out on our LinkedIn or on the mail base. I'll also chuck in a link to the brown paper tickets site there as well if you'd like to sign up. So yeah, that's it from us. Thanks again to our speakers. And there is one last question. Oh, okay. I'm interested in this thing. I think that's more of a general comment, so perhaps that could be picked up after, Hannah, if that's okay. Brilliant. Thanks again, speakers, and thank you for everyone for joining in. Have a good day.